Okay, here is the actual unit for honors quiz review, not to be confused with the one before that I thought was the honors, but it was the regulars. So here's question 1 of the honors unit 4 quiz review. So we have two line segments, segment AB and segment AB prime. And because it's 2 points, we only really need one. You could draw this on patty paper and transcribe it with some, you could draw this on some paper or whatever, and then you could transcribe with patty paper or plot it, but you really don't need to if you understand how to use the point comparison method and you know your algebraic descriptions and comparisons. So I'm going to use point B. Why not? All right, so let me grab colors, and it'll be make it a little fatter. I'll do point B first. That goes on top, and that's my initial point. Point B is -8 and 2. Okay, and my primed point has the point after the transformation is 2 and 8. 2 and 8. Right, so I'm going to look at generic terms at my point blue in terms of point red. That's my after point in comparison in terms of my before point terms. So my x coordinate of my new point was drawn from the x term of my previous point. So this is just, or my y term from my previous point. Okay, and my y term was drawn from my x coordinate, but it is the opposite sign. So it's going to be negative x. So that is my algebraic comparison. So the algebraic expression, x comma y, I guess this should be blue, but whatever. X comma y is y comma -x. And I know that when I flip and flop my x and y's, that is a rotation of 90 degrees. If I put it in front of the x, that is a clockwise rotation of 90 degrees. And if it rotates clockwise by 90 degrees, then it would also rotate counterclockwise. That's backwards. If it rotates clockwise by 90 degrees, and it would also rotate counterclockwise by 270 degrees. 270 degrees. That's 270 degrees. All right, so it's a counterclockwise 270 rotation. All right, so let's see which one of these paired up. Oh, look at that. There is my solutions. I have this one, this one, this one is drawn to this. I have this one is drawn to this. This one drawn to this. Okay, so moving on to number 2. Number two. A little long, but you can still do it with point matching ups. Like I recommend everybody use point comparison to solve these. They may be a little faster to do it with patty paper and stuff, but I don't know if you're going to have patty paper on the state exam. So get used to using the point comparison method. Okay, so it give us NHDW, and that is undergoes a series of transformations, and it becomes T, N becomes T, H becomes R, D becomes K, and W becomes B. Right, so I'm gonna go N. I'll do it up here, I guess. Over here, N, H, D, W, and pull coordinates off. My N coordinate is -9 for the X. So my X is, my H is -7. -7. My D is -4. And my W is -5. The Y coordinates are H is 3. D is 0. N is -1. And W is -3. All right. That's my first one. All right, so my first transformation is a reflection across the y-axis. It's going to reflect across this axis right here. That's small, isn't it? That axis. There we go. It reflects across the x-axis. Okay, so I'm not gonna take the time to plot it, but I will derive the points. Okay, so it's my new point coordinates that are going to become x and y are derived from the black terms. This is a reflection across the x-axis. So my algebraic description is x comma y yields, when it's reflection, the x's and the y's don't flop. I said x-axis, I meant y-axis, right? So the y's stay the same as it reflects, but the x's change polarity. So it's going to be -x, comma, y. We change sign. Okay, so let's get to business. Okay, so my new x is going to be derived, it's going to be pulled from the x column, but it's going to be the opposite sign. So it's going to be 9, 7, 4, and 5. And y's are going to be the same, pulled from the y column. 1, -3, 0, and -3. All right, that ends my red one. Next one's going to be a translation of left. So my delta x is left, that's negative. It's -3. My delta y is up. It's going to be +4. And remember, translations are x comma y. That's 4. Y is going to be x plus delta x, x plus y plus delta y. In this case, it's x -3 and y +4. If your delta x is negative, the plus turns into a negative sign. So in terms, my new coordinate pair for X and Y, X and Y are just going to be subtracting 3 from the X value, adding 4 to the Y value of the greens. Okay, so 9 minus 3 is 6. 7 minus 3 is 4. 4 minus 3 is 1. 5 minus 3 is 2. My Y's. Check that. Check, check, check. Okay. Y minus 1 is 1 minus 4 is 3. 1 plus 4 is 3. 3 plus 4 is 7. 0 plus 4 is 4. -3 plus 4 is 1. All right, and then my last one is a blue one. It's a rotation about the origin, but counterclockwise. So it's a 90-degree rotation. So it's X, Y. It's drawn from 90-degree rotations, swap the X and the Y. Counterclockwise ones, throw the negative in front of the Y. Okay, so this is going to be my comparison. My new X and Y coordinates are going to be drawn from the negative Y and the X of the previous coordinates. All right, so my X coordinates come from the negative Y of my previous coordinates. So that's going to be -3. Oh, what happened there? -3, -7, -4, -1. Then my Y coordinates are going to be for my X, not flopping the signs. So it's going to be 6, 4, 1, and 2, and that's my final transformation. So let me go ahead and zoom in, get everything. Yeah, I think I can get almost everything there. Got my little circle to fill it. Well, see that way. Okay, X is -3 and 6. -3 and 6. My next one is -7 and 4. -7 and 4. Next one after that is -4 and 1, -4 and 1, and then -1 and 2, -1 and 2. And that is E. That's double prime or something. Yeah, it's going to be T. Oh, this one's, yeah, whatever. It's this is where it's going to be located, right? So it's located in this area like this. Probably figure it out if I compare it. So my W lines up with my R. Believe. Yeah, whatever. All right, so I'll answer the question asked. All right, so which one of these does it look like it belonged to? Zoom out and make sure it looks right. Yeah, I can do that. All right, so these are the 4 choices. these are the 4 choices that it gave us, and you can tell that the answer A is the best one, right? Answer B was close. It was in the same quadrant, but it was inverted. Like the shape, this vertex here is pointing that way, whereas and answer B, this vortex is pointing that way. So that was kind of the giveaway there. That answer B was wrong. So aside from that, the other 2 are like way wrong, in the wrong quadrants. So answer A and answer B were close, but answer A is the correct one because it's dealt right the correct orientation. All right, so that is how you do number 2. That one was long. Whoa, that's what that color does. Okay, let me go with that. I want it to be white. Oh, white. Okay. And then back to black. Yes. All right, here we go. So going back to number 3 now. Hopefully number 3 is not as long. Number 3 is pretty much the same one, just only 2 transformations. All right, do the same thing. 2 transformations. All right, we have this triangle. It undergoes 2 transformations. And you can, and it tells you to pull out the triangle from after those 2 transformations. All right, so this one you have to actually pull out the coordinates. So I'll just go W, B, and H. B, W, my X coordinates are 4, and they're both 6 and 6. My Y coordinates is 6, 4, and 2. Okay, so I have the transformation, which is awesome. So for my red transformation, I have the algebraic description, and it even gives me my delta x's and my delta y's. So these are going to be negative. So for my, let's put that in a better spot. Here and here, here and here. My new x and y coordinates. I'm going to be pulling from the -7 values from x and the -3 values. I'm going to take 3 values away from y. All right, so that's going to be 6 minus 7 is -1. 4 minus 7 is -3. And 6 minus 7 is -1. Okay. Okay, so then here I got for my y's, my 6 minus 3 is 3. My 4 minus 3 is 1. 2 minus 3 is -1. So that's my new coordinates. Those should be red. 6 minus 7 is -1. 4 minus 7 is -3. 6 minus 7 is -1. 6 minus 3 is -3. 4 minus -3 is 4 minus 3 is 1. And 2 minus -3 is 3. This is wrong. 6 minus 3 is 1. Okay, 6 minus 3 is 3. Okay, check all those because I was kind of in a hurry. 6, 1, 3, 1, 3. That's wrong too. That is -1. Got it now. That's good. -1. Okay, I did it right the first time, but I was in a hurry to catch up. What happens? Always double check your work, especially if you're in a hurry. Okay. All right, now my next one, my last one is let's pretend I didn't even know what that is. I know what it is, but let's pretend I didn't know it. Okay, so my new coordinates is going to be here, right? And it's going to be in terms of this comparison configuration of my old terms And let me put my blue in there for my new XY. And my new X is going to be pulled from my opposite of my negative X, or my opposite of my old X terms. So it's going to be 1, 3, and 1. My Y's are going to be the same as my old Y's, 3, 1, and 1. Let's plot it with this. Okay, so 1 and 3. 3 and 1. 1 and 1. Oh, wait, there's a mistake. 1, there it is. This should be negative 1. 1 and negative 1. 1 and negative 1. Okay, connect them together. That was a reflection, by the way. That was a reflection across the y-axis because the x's and the y's stayed the same, but the y's stayed the same, but the x's flopped. Okay, so let's see here which one that one looks like the answer. Well, this one is not, it's not this, it's not this. It's kind of close to this one and this one, but this one's got the coordinates all off, so it is triangle Y. There you go. Moving on to the next one. This one gives us this guy. And it's like, hey, here are some translations. Give us the points of the after image of FGH. Okay. So this thing underwent a translation, right? This thing underwent the same translation. So B translated to our triangle ABC, translated to ABC prime. Okay. And FGH undergoes the same translation. So what are the coordinates for FGH prime? Right. So a couple ways you can do this. You can coordinate count. There's no reason not to on this one. It's pretty easy. You can coordinate count on a computer. All right. So my change in X is 1, 2, 3. So my delta, let's go with that. My delta X is positive 3. Right, because it went this way. If you didn't want to do it that way, you can go negative 4 to 1 is so my change, my delta equals your final minus your initial. My final was negative 1. My initial was negative 4. Negative 4. So negative 1 plus 4 is 3. Same thing. Okay. And then my change, that's my change in X. Okay, my change in Y. Change in, let's do it this way. I like to do it this way better anyway. Change in Y equals final minus initial. My final was 3. My initial, wait, no, we gotta use C. My initial, actually, we don't have to use C. We could, but we don't have to. Just because it's, say whatever, right? So my initial is no, we'll use B because it doesn't matter. It's just a delta, right? So my final is 5, and my initial is 2. So my change in Y is 3. So it's 3 up. I mean, that's the beauty of doing this, is you don't ever have to, as long as you do the math right, you don't have to worry about which way is positive and which way is negative. I mean, also it's pretty intuitive, but just as long as you do the math right, final minus initial, that's the unit analysis will always come out on top. So delta Y, delta X is always 3, right? So you can move this one up and over, and then you can plot point, or you can do it the table method, and that's what I'm going to do. I'm going to do the table method because I want Praxis doing the table method. So we do this. No, I want to do this. Okay. F G H. Initial points are -1 and 3. 3 and -1. 4 and -5. Okay, my new points in terms of X and Y are my old points. Whoops, nope, are my old points in terms of +3 of the old terms and +y of the y terms. And then, all right, so -1 + 3 is going to be 2. -3 + 3 is 6. 4 + 7. And 3 + 3 is 6. -1 + 3 is 2. -5 + 3 is -2. All right, let's see if those are on our thing here. Just a second. Wait a minute. This is wrong. This is wrong. This I mathed errored. Negative. This is -1. I just caught a few errors that I made, and can you believe it? I made most of them from pulling it from numbers. So this is -4, -4. So that's not right. That's a -4. Let me change that to -4. That makes this over here. Makes this -1. -1. -1. Get from Hurrian. -1, and then this is -3, which makes this wholly wrong. So this is 0. This is 0. Yeah, so that's what happens when you pull coordinates wrong. Throws your numbers all off. Okay, so now let's check to see if any of these are the answers here. Pull it up. And where did that question go? There it is. Okay, so there it is here. So there is the so here is the two things here, and then so you can see here that we got 2, 0, 2, and we got 6 and 2. We got 7 and -1. So there is our 3 answers there for that one. Okay. So sorry about pulling up those again. That is the number one thing that I do wrong, is pull coordinates wrong in my hurry in these things. So a lot of people make that error too. So learn from my mistakes. Don't learn from your mistakes. Okay. So here we go. Well, you should learn from your mistakes, but learn from my mistakes instead of your mistakes, so you don't make them. Okay, so here we go. This one was a word problem, so it was real tough for people. All right, word problems are hard. All right, so while vacationing, girl sees a mountain and it reflects a lake on the water. Great. The mountain is a reflection on a grid, and it's the axis is a line of reflection. It's a line of reflection across the x-axis. Okay, it's reflecting across the negative. It's reflecting these coordinates. What are the other coordinates? Okay, so this thing is just saying I'm reflecting this coordinate across the x-axis. That's all this thing's asking. Okay, So if I have a coordinate pair, don't read too much into this thing. Just crack the code, right? Just an x-axis, and it's reflecting, right? Okay, it's reflection across the x-axis. So a little absurdly bad here, right? So if I have the reflection x comma y, whoa, that's a crazy y, right? And a reflection across the x-axis. Reflections keep x and y the same. The x's are the ones that change, right? So go like, wait, no, the y's are the ones that change. X's stay the same, right? So if I have an x and a y, right, and it goes like this, it goes like this, right? It rides the x-axis, right? It doesn't change the x-axis, but the y is flip and flop, right? It's reflection across the x-axis, okay? So anyway, that's why the x stays the chains, but the y flip and flop, okay? Anyway, or it does this, it rides that way, that way. Okay, so anyway, so I have 6 and -8. So I start off with uh -6, -6, comma, and 8. Okay, I'm gonna apply this code. All right, so my 6's stay the same. So it's -6. My y's stay the same, but the sign changes, -8. So your new coordinate point is now 6, 8, -6, -8. All right, there has been a couple glitches from Math Nation on this one. If you answered -6, -8, sometimes people saw that it was answering it incorrectly. If that happened to you, screenshot it, message it to me. I will let Math Nation know, and I will adjust your grade accordingly. Moving on to the next one. Okay, we have, all right, this one, I owe you guys an apology on here. So I led a couple people astray. I read it a little more closely, and so those are led astray. I'm going to comp you the point. So I have an x and a y axis. This is x, this is y. Okay, got 1, 2, 3, 1, 2, 1, 2, 1, 2, whatever. Okay, I have a line and a y intercept. Just think of your point intercept equation, y equals mx plus b, or y equals mx plus b, right? Well, that would be a bad for it. So if you have a slope, or if you have a line that doesn't have a slope, the slope is 0, right? And it intersects at the y equals 1 or y equals 2, right? That means that for any value of x, for any value that I put in for x in here, y will equal 2, right? So if I put like, say I have like x equals 5, right? Y will equal 2. x equals 7, y will equal 2. So this is the line y equals 2, right? If I draw a line down here, that's y equals -2. This is y equals 0. Okay. This is x equals 2. Right? Because no matter what point I have on y, let me change these colors. This is x equals 2. This is x equals -2. That's the line. So no matter what point on y that I have, x is going to equal -2. Okay. This is like a little bit of pre-calculus-y stuff, right? But if I put it here, this is x equals 0. For whatever value of y that I have, it doesn't matter. X equals 0. So this is not x equals 0. This is y equals 0. So that's where a lot of the misconception was. Why a lot of people thought that they got it right when they did not get it right. Because I glanced at it in passing and I was like, yeah, that's right, but it wasn't. So anyway, so how do we do this one? Right, so we have a point, -3, -7 is reflected across some line, right? And this is the resulting point, right? And it wants us to know what is the line, and then describe how the point is done, right? Describe the point relationships, right? So the two drop downs are pretty easy. The line part is the tough part, right? So just start with point comparison to give you the algebraic description. And from there, you should be able to say, okay, what's this type of? But then the biggest thing was you had to understand what I just described. I think I should leave that up. Okay. All right. So the reds are the y equals. I should put that up there. So these are the blues are the x equals whatever. And then the yellows or reds are the y's equal whatever. It's the y-intercepts. Okay. So it's a little counterintuitive. Whatever. Okay. So here we go. So let's put up the p prime. Okay, and then let's put up start the p and then the p prime. And then put up the comparison of p in terms of p prime in terms of p. It stayed the same. X stayed the same. The sign stayed the same. Y value stayed the same, but the sign changed. -y. Okay, so this is a reflection. Okay, the y changed. So it went from here to here. It rode the x-axis, but the y changed. Okay, so this is a reflection across the line y equals 0, because that's the y-axis, not x equals 0, which many people answered was x equals 0. That's wrong. And I didn't correct many people. All right, but it's y equals 0. So if you answered this, I'm still going to copy it. All right. But y equals 0. Okay. And then because the x coordinate stayed the same and the y coordinate is opposite. Right. So that is what he called out for right here. And that's why. Okay. Sorry about that for those that led astray. Hopefully that clears up anything that was confused. All right. Number 7. Number 7. Okay. Number 7 here, as we have the triangles, identify the transformation. Well, this is like Groundhog Day here. We have A, B, and D, because why not D? Why not? It's C's day off. Okay, so let's just pick one that is not like don't pick a point. Yeah, I don't even need all 3 of these. I just need one. Right. Let's pick a point that doesn't share the absolute value for the x and y coordinate, because that would make things complicated. All right, so let's pick A. Right, A's x coordinate is -8. Y coordinate is 2. Okay, now B's A prime's x coordinate is 8. And its B coordinate is -2. Its x coordinate is -2. It's A prime. So the x coordinate, that A prime coordinate in terms of the A coordinate comparison is as follows. The x values, absolute values, match up, but the signs change, so it's -x. The y absolute values match up, but the signs change, so it's -y. So the algebraic expression is x comma y, drawn from -x y, and that is -y, and that is a rotation of 180 degrees, if you know your algebraic descriptors. All right, and about the origin, about origin. All right, because if you can see that if you go like this and you rotate it 180 degrees, it's like, whoa, there it is, right? And that's that, right? So if you do this, you can see, yep, that was the answer. Rotation 180 degrees. All right, moving on to 8. A few more left. Got 3 drop downs. Okay, 3 drop downs. Okay, we have 3 triangles. This is a series of transformations, and again, you're doing the table format. All right, we're going to start with E, F. Wait, it's telling you to. Oh, it's just asking you the different things. You only need one. You only need one. You only need one of these. All right, let's pick E. Yeah, let's pick E. Yeah, sure. Do E. E prime. E prime or E. And then so E started off as 6, 5. No, that's way wrong. -1. Right, and then it changed to -6, -6, -1, and it changed to -1 -6. Z prime. Prime. I should change that color. Let's do the same condition here for everybody. So B prime is -6, -1. So this, in terms of black, is that stayed the same. Wait a minute. Well, that's not right at all. Pop it down again. This is -1, -6. Right? Let me go check this one. -6, -1. And then this, oh, that's E double prime. Man, I gotta pay attention to this stuff here. Let me just start all over because I'm confusing myself. Okay. When you get that far, like something like that, just start all over. I mean, I'll get on the right path, but I'm sure you guys are confused right now too. All right. Let me just start with a new. Let's do G. Let's do G. Wipe everything clean. Let's do G. All right, G is -3, -3, and -5, -5. G prime. G prime. So here, and it is 3 and 5. Okay. So this, in terms of this, that changed. That stayed the same. Signs changed. Signs stayed the same. Okay. So this is a 180-degree rotation. My first one. And then I don't need to do that. This. And I'll go 3, 5. And we'll go, I believe, my G double prime. G double prime is 5, -3. So this in terms of red, that got drawn from that. So this was my old Y. Signs are the same. This was my old X, but that's negative now. This is a, well, that is a clockwise rotation. 90 degrees, about the origin. Okay, so let's see if, oh wait, that wasn't an option. Whatever will I do? That was not an option. I had 90-degree counterclockwise, 180-degree clockwise, and 270 counterclockwise. Well, remember, if I have 90-degree clockwise, right? That's the same as 270 counterclockwise. Right, so your answers are those two. 180 about the origin. 180. 180 about the origin. And clockwise 190. 270 counterclockwise. You just can remember that. So there you go for that one. Number 9. Number 9. Okay, so this one's a steamer here. Okay, so here we go. Sequence of transformations. Done. Complete the algebraic descriptions for the drop down. Okay, so I just want you to know, it wants to see, and so again, this is the same thing again. So we just need to grab one from the prime. Let's do B. So B, black. Way up here. B. -8, -4. -8, -4. B prime is 4. -8. 4. -8. Okay, so this is B prime. So this relationship here in terms of this, we go the y got, so the x got drawn from the old y, and it is negative. So it's going to be -y, comma, the x's are the same. So that is a rotation clockwise, counterclockwise, 90 degrees. Okay, then we're going to go red. Red is from, we're doing B. Red now is B. Yes, B. And from B, I guess that one is B. Let's see if I can take a look on that. Okay, yeah, so this one is B double prime. That's B double prime. It's kind of hard to see on there, but that's B double prime. And so that one is 4. Is 8. It's -8. No, that is 8. That is 8, comma, -4. -4. Right. So in the terms of blue, this is going to be -y. I mean, this is -x. And that is a -y, -x. That is a reflection. Reflection across -y equals x, or x equals -y, whatever way you want to look at it. Okay. And then the last one is it looks like it's a translation. So I'm just going to coordinate count. So this is 1. No, I'm not. No, I'm not. This is going to be my initial. My delta x is final minus initial equals my final B is 15. My initial B is 8. That's 7. My y is final minus initial equals -4 minus negative 1, 2 minus -5 -4. Oh wait, no, it's not right. Final is -5 minus -4. -5 plus 4 equals -1. So this is going to be x plus 7 comma y minus 4. Cool. All right, so let's see if those are any of the answers. What, y minus 4? Why did I say y minus 4? That's not right. That's 1. That's not right at all. That's 1. That's more better. Okay, so here we go. Let's see if those are right. Where'd that answer sheet go? There it is. Pull it into focus and pop that. And here it is. Big there. All right, so there you go. There's the answers. Negative x. Oh, what did I mess up? Negative y comma x. How did I mess that one up? Your y's. Oh yeah, your y changed and your x didn't. Yep, definitely made that mistake there. Your y changed there and your x didn't. I made that mistake right there. Okay, and your negative y negative x, and then your x plus 1 x minus 1. Yeah, so there's a mistake right there. So right here I made a mistake. So your y is your negative. Pull from your negative, that changed for sure, and then your x. Oh, wait a minute. Down in there. I'll have to go back and look at that one and see where I made a mistake. It's your x, your y, your x coordinate. I'll have to see what happened there. I have to go back and look. Let's do that now. See where the mistake was made. All right, so let's see. B was -8 and -4. Okay, and then my B prime was, oh, that's my mistake right there. My B prime things were wrong. My B primes are wrong. It's -8 and 4. Well, that's my mistake. That's my problem right there. I misread my stuff again. Okay, well, there we go. I would have got that one wrong, everyone. So there we go. That one is a y and a negative x. So there we go. That's a rotation clockwise 90 degrees. No, it's not. That's a x comma negative y. That's a reflection. That's a reflection across reflection across reflection across the y changes, so it's across x. All right, so that is where that makes me feel better a little bit, although I would have got that one wrong still. Partial credit to me if I was grading, but Math Nation was, so I would have got that one wrong. All right, so Anyway, so I would have got a 90, everybody. If you would have beat me on that one, then good job. Okay, so here we go. Oh, what happened to the quiz? Where is, let me pause it real quick so you guys aren't listening to me ramble. Okay, so moving on to number 10. And we have a line segment that's reflected across y equals x. And remember, y equals x is this line right here. For every one change in y, we have a change in x. So it's a reflection. So again, use the table. You have A is -3. You have y is 4. No, y is 1. Then you have B is -1 and y is 4. Okay, so we're going to apply a reflection across the y-axis, and that is y comma x. That would reflect that. Y comma. Set it up the same so it looks the same. I knew x and y term. New x and y term. From is y is the old y and the old x. A prime, B prime. So it's going to be 1, 4, and -3 and 1. So let's see if that is a group of answers. And -1 and -3. 1 and -3. Okay, and 4 and -1. 4 and -1. Forgot to move that negative sign over to there. So, yep. So that's it. That is the entire. Looks like I would have got a 90 on that one, guys, unless I gave partial credit. Then I would have got like, I don't know, like a 96 or something. So anyway, for those of you who got 100, good job. You would have beat me. So have a great rest of the day, and I hope this helped you understand everything.